Hey, what's going on, guys? Xiangqi here. Just before we go for perf testing, I'd like to demonstrate one more in between steps, so how we do make and unmake moves on the internal board, array basically. So without further ado, let's actually first go for demonstration, and then I'll quickly walk through the code that has been added and changed respectively. So it's gonna run this. Okay. Okay, so we just get initial board position and now wait for key input to. I'm just breaking the program flow to show how this make, move, and take back is doing. So just to give you an idea what kind of code currently gets executed. So here in my custom perfed, this is the loop we're currently at. So it prints the board, then it does the move, prints the board, waits for user input, then unmakes the move, prints the board, and waits for user input as well. So know that site to move is changing every time the move is made. I'm not yet incrementally updating hash keys. This is about to be implemented a bit later. And also I do keep of the kin squares if kin is changing its location. This is needed in order to later on to ask, is the square attacked, sending the kin square as an argument. So let's have a look. So we're moving the rooks, the knights, the bishops, advisor. Now have a look at the kin square. So kin moves, square changes, so red, black also changes all the way, and here we go basically. So this is just a pseudo-legal move generator, so at the moment it doesn't really check for checks, and this would be the part of the make move function as I've been mentioning before, but for now, by the way, yeah, you've seen it has restored the captured piece. So just quickly show you this one more time. So when the guy comes to the cannon, so now it will capture this knight, because that's the nature of cannon captures, just only over the piece, no matter own or opponent's piece. And then it goes back, the piece gets restored. So the very basic functionality of make move and take back move functions. Okay, so now let's go to the implementation. So I've removed the original Stockfish's code completely because we don't really need tons of things there like handle, castle, and peasant and all this stuff. So now the code is very simple. So this is just a placeholder to a given warning for this variable is unused. As soon as I get rid of this variable, this line is not going to be needed anymore. I've also added the search ply to the position instance as the internal data field. I have no idea where Stockfish is holding the search ply, so probably somewhere within the search structures, I don't know. But I really used to keep track of this within the position itself. It's really handy because search ply is something, well, it's arguable whether it's something that corresponds to position or to the search. It's really arguable, probably architecture dependent, but it's really easier for me to keep track of this stuff like this because I know the search ply and the game ply gets updated in one same place, so I can easily control them. I didn't yet deal with the repetition table. I'm also using I would be using my custom implementation of the repetition table, not implemented at the moment yet. Okay, so here we push hash key and well, in CNC this is not a rule 50 but rule 60 because we have 60 rule move counter for a draw, not 50 rule move. So we push this to the stack. Okay, yeah, by the way, I should have also print the 60 rule move, yeah, just to make sure that it gets updated correctly. Okay, and then we just kind of like copying this the current stack state. Then we extract that source and target square from from the move that is taken as an argument to the doMove function. Moving piece on board, so it's very simple, nothing really to show, like just to reset the stuff on the source square. Yeah, by the way, yeah, for performance reasons, as I do here, this probably could have made sense not using this, not using the method, but actually directly accessing the data fields. I know this is ugly, but this should be a bit faster, I think. Well, probably the highly optimized compile code does this automatically for us, not sure, but well, anyway. So in case if we have a capture, we do reset the 60 rule move counter, okay. And also we need to update the kin square every time we have the either white or black kin on the target square. Finally, we need to switch the side, so I'm just using the XOR operator to convert 1 to 0 and 0 to 1 every time we XOR with 1. Black is the constant of 1, but it's the type of color. Okay, and also, yeah, like updating the hash keys is not done yet, because I'm gonna be simplifying the way of generating and keep tracking of these hash keys. And one of the core things is to answer the simple question whether the move is legal or illegal, based on if the kin is left within the check after the move is made. We just want to take this move back and return 0, which means the move is illegal. Otherwise, we just return 1 and the move is okay. And in that case, the routine here would be slightly changed. This would be like if doMove returns true. In this case, we're just doing this move. Otherwise, we just continue the loop. That's the way to go. Okay, so and the take back function is literally the same. So just decrement applies, moving piece back, putting piece on the capture square if the capture flag was available, updating the kin square again, like changing the site. So it's very, very simple. So compared to international Western chess, this make, move, and take back functions are really simple. So the next step to consider, well, I would probably like to debug this 60 rule counter. I'm not sure if it does have an interface like for 50 rule move counter. There should be. Let's have a look actually. So position. Oh, this is it. So we can actually go for it. It also gives the ply. So let's call this one rule 60 count and return rule 60, and here okay, and now we can say rule 60 and position by the way, I probably don't need this parenthesis here, right? So rule 60 count, and let's try to compile a run again. Yeah, just forgot to do that. So every time we're making a move, it should be incremented by 1, and if it's not a capture, it still gets incremented every next supply, and if we capture, it should get back to 0. Just will reset the counter. And like this, and then yeah, by the way, yeah, within Within the set FEN, I've also added a bit of a code to reset both search and gameplay. So in Stockfish it was done somewhere else. I really want to make it here explicitly within the parse FEN. That's the way how we used to do this stuff. Also do reset the kin squares. So made this little interface for resetting that. Also that would be, I need to do the same with the repetition table. And yeah, also probably moving this sort of a thing to types. However, it probably won't be possible to initialize within the H file, or no, it's possible, or I don't know. I don't even know. Well, it doesn't matter really. So yeah, let's have a look. So now we have this rule 60 out of the way. I just need to yeah, it's a little bit strange that rule 60 is not getting updated. So did I forget to put that? So this is the JavaScript source of my engine that I'm referencing. So make move. Okay. If not a capture flag, hold on a sec. Oh, probably just, yeah, just because, hold on a sec. It should be just so yeah, after this works, I can then go to, yeah, you see rule 60 was equal to 1. Yeah, so just not seen here because it just gets restored. So when we do make a move, or hold on a sec. Hold on a sec. No, it's just some weird crap. Hold on. As far as it does get updated, let's see for this count. Rule 60 count. State rule 60. No, I need rule 60, not from the state, but from the actual data field. Yeah. So it's slightly changing the architecture. It's not the architecture really, just slightly changing the way of how to reference the variables. Just try to make it more clear and simple, easier to understand basically. Okay. You know, guys, this sort of a butchering of Stockfish's source code actually has one big upside, that I'm really kind of learning how the original Stockfish was working before I ruined that. That's real fun. Okay, so make move. Yeah, rule 60 now gets updated. Okay, and on the capture it shouldn't be updated. So now we just go for a cannon move. And the next move, now I hit enter, and it shouldn't be updated. Okay, because it gets resetted here. Okay, gets resetted. Good. And all the rest, most as far as they're not captured, also gets updated. And now, no, it's not because of the capture. Yeah, okay guys, so I think this is it. So yeah, the next thing is to just to port my square attack function and actually trying to run the perf test. One of the very biggest milestones when you're developing a chess engine. And sorry, just bearing in mind the fact that we actually did make this move generator completely from scratch. So yeah, it's a really big milestone. So yeah, that would be really fun to watch. Especially, I'm really tempted to know how faster it would be, because you know, like even my JavaScript node generator that is available here, my OpenJS sources, it's even slightly faster than the node generator in the Chameleon chess engine, which is the derivative of the Stockfish 7. Can you believe that? That's hard to believe, but I have a video comparison. Have a look at the second video within this Xiangqi Stockfish playlist on chess programming channel within the playlist section if you're interested. But I think, well, probably this would be the next video. I'm gonna be making a new comparison, so like how this current mode generator in C++ would be performing compared to those already exist, like the one in Fairy Stockfish and another one in Chameleon. So this is it from my side, guys. Thanks for watching until the next time, and take care.